This question is a variation on the half-life equations that we handled in the last video. This question says if we start with a population of 100 rabbits on an island, and it takes 9 months for the population to double, how many months will it take before you have 1,000 rabbits? Notice the difference between this and the half-life questions. We're having the population double rather than having some amount of mass of a chemical being cut in half. If something is doubling, we'll instead use a doubling time equation, which is similar to a half-life equation with one key difference. The equation for doubling time is still y equals p times 2 raised to the x over d. Note that we are using 2 as our base rather than 0.5. However, p is still the starting amount. X is still the time that has passed. And rather than h, we have d, where d stands for the time to double. Y is going to be the new amount after that time has passed. Once you've selected the correct formula for the job, it's a good idea to have a look at the quantities that you do know. We have a population that starts at 100 rabbits. This starting population will be our p, and we'll write that down underneath. It takes 9 months for the population to double. That's our doubling time, and we'll call that d. Then we were asked, how many months will it take, meaning we don't know the time, that's x, but we do know we're going to reach 1,000 rabbits. That's our new amount, and our new amount will be y. So y is 1,000. This means we know y, p, and d, and we're going to be looking for x. Now let's place the numbers that we do know. The y on the left is 1,000. The p on the other side of the equal sign is 100. Multiply times 2 raised to the x over the doubling time, which is 9 months. Here we have another exponential equation. For an exponential equation, we need to get the exponential by itself, then take a log. To isolate the two, we'll begin by dividing by 100. 1,000 divided by 100 will give 10. We'll set that equal to 2 raised to the x over 9. Then we'll take a log on both sides. On the left, we'll have 10, because we'll bring the 10 down into the parentheses on the right, and then the 2 raised to the x over 9 will go to the other parentheses. Now we'll simplify these logs. On the left, we have log of 10. Now remember that a log with no base written automatically has a base of 10. If it helps, you can write the invisible 10 down here under the log. Now, if we have a log with a base of 10 and a 10 inside, it turns out these are inverse functions. If we try to cancel this out, we can rewrite this as 10 to the first power and put the invisible 1 as my exponent. Then we can cancel out the log base 10 and cancel out the base of the exponential 10. This leaves behind just the invisible 1. This leaves us with a 1 on the left. On the right, we can take the exponent, x over 9, and move that down to the front. If we make that move, we'll have x over 9 times log of 2. Now we're going to try to isolate x. To begin isolating x, we will multiply on both sides by 9. As we cancel out the 9's, we now have 9 on the left, which is 9 times 1, equals x times log of 2. Our final operation will be to divide by log 2. Therefore, my x is equal to 9 over log 2. If you want to get an approximate answer to go with this, you can always go to a calculator. If we divide, we get 29.90 months. This will be the time that has to pass in order to reach a population of 1,000 rabbits.